This is Mr. Anderson for Kellogg Community College. This is for the fourth section of Chapter 8, Applications Involving Quadratic Equations. Buckle in, we're going to do some story problems that all have quadratic formulas in them. And because I've been doing a lot of sections with quadratic formula, once we get the quadratic written, I will not be actually processing the formula. I will actually not be typing in and showing you every little step to solve negative b plus or minus the square root of b squared minus 4ac divided by 2a. If you have struggles with these, please go check earlier videos. Our goal for every single one of these problems is to get them so that they work out so they can be you can actually do the quadratic formula with them. And we're going to start off with problem number 1, which is very similar to problem number 4. So it might be beneficial for you to do problem 4 after this one if you want some practice. During the first part of the canoe trip, Ken covered 60 kilometers at a certain speed. So this is a distance equals rate times time problem. And we've made some d equals r times t little matrix boxes before. And what we're going to do here is plug this in the more we know about the story problem. So it looks like he says he covered 60 kilometers at a certain speed. So he went 60 kilometers at some certain speed. We don't really know the time yet. Then he traveled 24 kilometers that was 4 kilometers slower. Okay, so he just went r minus 4, whatever that speed was, he went 4 slower. Now, if the total trip was 8 hours, what did he spend on each part of the trip? Now, here's the real kicker. The first time and the second time of the trips are unknown, but we know that the total for the trip was 8. So that means that t sub 1 plus t sub 2 is equal to 8. So we know that these two equal to 8. So somehow we have to get an equation to fit into this part here so we can plug something in for t sub 1 and something in for t sub 2 and then solve for the variable we're looking at. Now, the problem is asking what is his speed? So I think we're trying to solve for r here. Well, let's go and see what we can do. My first equation is, and I'm going to color code these so this will help a little bit. Let's go to light blue here. So my first equation is going to be 60 is equal to r times t sub 1. Now let's get the t sub 1 isolated and plug whatever we get into our t sub 1. So this is going to be 60 divided by r, since the inverse operation of multiplication is division. So 60 divided by r is equal to t sub 1. So t sub 1 is 60 divided by r. Alright, let me change colors to look at the second equation right here. The second equation is going to be 24 is equal to, because this is distance equals rate times time, the parentheses of r minus 4 times t sub 2. Well, since we want to plug it in here, let's get our t sub 2 isolated, so we're going to divide both sides by r minus 4. And what this does is this simplifies to 1, so t sub 2 is equal to 24 over r minus 4. So we're going to have 24 over r minus 4 in our equation. Let me change back to blue here to show you the parts of the equation that haven't changed at all. They're still being added because the two times together will add up to 8 hours. So what we're going to have to do is take this equation and solve for r. Now I'm going to rewrite it kind of like a line right here, and anything past this line is going to help us kind of do the problem. So let's go with 60 divided by r plus, now I'm going to give myself some room here, 24 divided by r minus 4 is equal to 8. Now we need to clear these variables out of the denominator, and to do so we're going to multiply by the lowest common denominator. Now the lowest common denominator of r and r minus 4 is, well, r and r minus 4. So r and r minus 4 gets multiplied by each of these expressions. Now what happens here is, since we've multiplied everything by r and r minus 4, which is a legal step, this legal step allows us to do some canceling so the denominators get removed. R divided by r is 1, r minus 4 and r minus 4 is 1, and this 8 is going to get multiplied by the quantity of r times r minus 4. So now let me switch colors again and get to where we can do some simplifying. 60 times r minus 4 is 60r minus 240. I'm just multiplying the blue 60 by the red r minus 4. This blue 64 multiplied by the red r is just 24r. Now this 8 is being multiplied by r times r, or r squared, and then r times negative 4, which is negative 4r. So 8 being distributed by these two things, because this is really what these two are getting multiplied by, this is going to be 8r squared minus 32r. Now what I'm going to do is I'm going to move everything to the right side. The reason why is I kind of prefer to have 8 being a positive number. I like having my number in front of my r squared to be positive. So I'm going to subtract the 60r and subtract the 24r from the negative 32r, and that's going to give me a negative 116r. I'm also going to add the 240r to both sides. That will give me that at the end, positive 240. Now since I moved everything to the right hand side, the only thing on the left hand side is 0, which means I now have my quadratic where a is equal to 8, my b is equal to negative 116, and my c is equal to 240. Now this is the part I'm not going to, compute all the way down for you. The quadratic formula starts off with negative b plus or minus the square root of b squared minus 4ac. Now I've done some computing on a scratch piece of paper, and I found that that determinant is going to be 5,776 divided by 2 times a, and 2 times a is going to be 16. 5,776 is a perfect square root, so this is 116 plus or minus 76 divided by 16. Now because this is a story problem, this is going to have two answers, but only one answer will make any sense. If I add the 2 and then divide by 16, I get an answer of 12. Now if I subtract these two and divide by 16, I get 2.5. Well, only one of these makes sense as the speed of which we were traveling, because notice that we're finding r, which is the speed, and the other trip was r minus 4. If we chose the smaller of the two numbers, 2.5 minus 4 is a negative number, and we can't have a negative speed. So therefore 12 is our only answer, so r is equal to 12, which also means the other r, which is the speed on the other part of the trip, which is 4 kilometers slower, is 8. So these were the two speeds for that problem. Now we're going to do a problem very similar to this in problem 4. So let's try problem 2. Let's change paces a little bit here. This is another distance equals rate times time problem. It takes a different look though, because this is Stuart driving a car 280 miles averaging a certain speed. Isn't it annoying that they don't tell us what that speed is? But that's really part of the problem. The problem is to find that average speed. So he travels 280 miles averaging a certain speed. Now, if the car had gone 5 miles per hour faster, the trip would have taken 1 hour less. Find Stuart's average speed. Now, it's really kind of tough to set up the equation here, so let me kind of walk through the logic of it. Stuart's car travels 280 miles. All right, but we don't know his speed, and we also don't know his time. These are both mysteries to us. Now down here in the second clue that we got is that if he had gone 5 miles per hour faster, so if he went r plus 5, then the trip would have taken 1 less, or t minus 1 less. Now he's still going 280 miles. This is just part of the equation right here because we know that he's traveling this far. So he went 280 miles at a certain speed, but if he would have went 5 miles per hour faster, it would have taken 1 hour less to get there. So the big question is, find Stuart's average speed. Now what this means is we're trying to find r. So we're going to see if we can do kind of the same thing again. We're going to try to see if we can kind of make everything in terms of r if possible here. So how are we going to do this? Well, take a look at my first equation. My first equation is going to be 280 is equal to r times t. Now, since I am trying to find r, what I'm going to do is I'm going to move the r to the other side and get my t all by itself. So t is equal to 280 divided by r. Now watch this little trick here. You see where this second equation, which I'm going to use in a different color here, and I'm going to just write it out, and it's not going to be so apparent yet as to what I'm going to do, but something nice is going to happen. So I'm taking this bottom equation and I'm going to kind of transfer it over here, and I'm going to have 280 is equal to r plus 5 times, and here's my binomial work here, t minus 1. Now, do you notice that this dark blue is t and this light blue is t? If I substitute, and I'm going to change colors here, hold on. If I substitute this here into this here, what I'm then going to have is an equation with absolutely no t in it. It's just going to have r, the thing I'm trying to find. So let's go take a look at that. I'm now going to have, let me again try to color code this so you can kind of follow along here. I'm taking my second equation, which was 280 is equal to parentheses r plus 5, and in this spot for the letter t, let me change colors here to 280 divided by r, and then change it back here to the other color, so you could see that the only thing I did was substitute in that 280 divided by r in for the letter t. So what I have now is I have this FOIL problem that I can use to get what I need. So let's start foiling. Let me go change to dark blue here, because that's the problem we're gonna be pretty much doing this whole thing right now. 280 is equal to, okay, so my first cable, this times this. Now r times 280 divided by r is just going to be 280. So the r's simplify. Then r times -1 is negative r. Now I've got 5 times this 280 divided by r. So this is going to give me a pretty big numerator here. This is going to be plus 1,400 divided by r. And then this 5 times -1 is -5. Now, here's what I'm going to do. I'm going to do a little bit of simplification, and then I'm going to do some pretty cool stuff to kind of get me what I need here. I'm going to move the -5 over to the 280. So I've got 280 is equal to 275 minus r plus 1,400 divided by r. And we're still trying to figure out, like, what's our process here? What's our plan? Well, our plan at this moment is to clear the denominator of the variable r. So what I'm going to do is take every part of this entire equation and multiply it by the letter r. Now what this is going to do, it's going to give me 280r. It's going to give me 275r minus r squared plus 1,400. You'll see that the 1,400 r over r is just going to give you the 1,400 here. Now what I'm going to do is move everything over to the left hand side. I'm going to move my r squared over, so it's now a positive r squared. I am going to subtract the 275 from the 280, so that just makes a positive 5r. And then I'm subtracting the 1,400, and now that's equal to 0. Now there was probably more than one way to get to this spot, but now what I have is my a is equal to 1, my b is equal to -5, my c is equal to -1,400. Now we get to play the quadratic formula. 5 plus or minus the square root. Now I did my determinant, which is the -5 squared, minus 4 times 1 times 1,400, and I got the answer of 5,625 as my square root. All over 2 times a, which is 2. Now, what's great about that is the square root of 5,625 is a perfect root of 75. So here I have 5. Oh, wait a second here. This should be a plus, which makes this a plus, and that's a negative. Sorry about that. A little fix there. Got to go back and fix that. Again, this is a plus 5. This is a plus 5, so this would be a negative 5. So it's negative 5 plus or minus the square root of 5,625 divided by 2, and that makes negative 5 plus the square plus 75 divided by 2, or you can have an answer of negative 5 minus 75 divided by 2. Now if I do it this way, plus negative 5 plus 75 divided by 2, I get an answer of 35 miles per hour. And 35 miles per hour makes sense. Now if I do this answer, which gives me negative 80 divided by 2, which is negative 40, this does not make sense. It does not make sense, so we are not going to take that answer because we are not going to drive a negative speed. So our answer to the problem is 35. So Stuart's average speed was 35, but if he only went 5 miles per hour faster, his time would have taken a lot less. Problem 3 is a lot like problem 2. So we're going to get another crack at this problem here. Hopefully I won't miss the negative the next time. And this is another distance equals rate times time problem. So here we go. Distance equals rate times time. A turbojet flies 50 kilometers faster, 50 miles per hour faster than a superprop plane. And a turbojet goes 2,000 miles. Here, let me put down this for the turbojet. 2,000 miles in 3 hours less time than it takes the superprop to go 2,800 miles. Find the speed of each plane. So we're finding another rate here. Alright, so let's look at this here. So 2,000 for the turbojet. I'll just put the jet here, and this is going to be my prop. Alright, so how am I going to kind of write this out? Well, let's see here. I'm going to say that my jet, it's going 50 miles per hour faster than the superprop plane, so there's my superprop, and this is going to be my R plus 50 for my turbojet. Then I'm going to notice that it takes 3 hours less time, so this is going to be t minus 3 to give me what I need here for the jet. Now let's write my jet equation first. 2,000 is equal to parentheses r plus 50 parentheses t minus 3. Alright, because distance equals rate times time. Now, what I'm trying to figure out is if there's a cool way for me to get rid of this letter T right there, I'd be all for it. Well, there is. Let me quickly change to a different color, and what I'm going to have here is I'm going to have T is equal to, or T is multiplied by R, which is equal to 2,800. Now to get T all by itself, I divide both sides by R. The R's simplify, and therefore 2,800 divided by R becomes this T value right here. So this gets plugged into T because now I have this 2,800 divided by R that goes right there. Now I'm going to write everything else in blue so you can see that that's the only thing I kind of did in that part of the problem. Take your 2,000, I've got R plus 50 minus 3. Alright, so what I'm going to do now is FOIL all of this. I'm going to FOIL it, so R times 2,800 divided by R is just 2,800. R times negative 3 is negative 3R. 50 times the 2,800 divided by R is going to be positive 140,000 divided by R. And then 50 times negative 3 is negative 150. And that's equal to 2,000 over here. So it's time to do some more simplification. I'm going to take my 2,000, I'm going to take my 150 away from my 2,800, and if I do so, I'm going to get an answer of 2,650 minus 3R plus 140,000 divided by R. Now at this moment, what I'm going to do is multiply both sides by R. Multiply both sides by R, and the reason why I'm doing that is because I want to clear this R out of the denominator. So I have 2,000R is equal to 2,650R minus 3R squared plus 140,000. And the reason why I have that 140,000 instead of 140,000 divided by r is r divided by r is 1. Alright, well, it's time to manipulate this equation and get it so that it looks more friendly to the quadratic formula. I'm going to move the negative 3r to the left side so it becomes a positive 3r squared. I'm also going to move the 2,650 over to the 2,000, which gives me a negative 650r. And then I'm going to have my 140,000, move that to the left, so it becomes negative 140,000. Equals 0. So what we have now is my quadratic formula set up. I can put my a as 3, my b is negative 650, and my c is negative 140,000. Now what this gives me here is this gives me a perfect setup right now for me to do the quadratic formula. So I've got 650 plus or minus the square root, and when I do this square root, whoa mama, this determinant turns out to be 2,102,500. Lucky for us, that's a perfect radical. And 2 times a is 6. Or 2 times 3 is 6 there. So we're going to take the plus and minus of each of these, and I did some work on the calculator. The square root of that 2 million number is going to be 1,450. So we add these two numbers up and divide by 6 and get an answer of 350. Now you're probably wondering why I don't even entertain the option of subtracting these two and dividing by 6. And the main reason is because that would give me a negative number, and we're not going to have a negative speed. So the speed of each plane, the slower prop plane was 350, and the turbojet is 50 more than that, so your answer for the jet is 400, the prop plane is 350. Alright, and we're going to do one more problem, then we'll draw this video to an end. This problem is very much similar to the first one we did, so if you want to see a little refresher here, this is where you're going to get it. Okay, so distance equals rate times time, and the distance it looks like Mark is going 600 miles averaging a certain speed. Well, I have no idea how fast that is, so I'm just going to put 600 in the chart here. Now, a return trip is made, okay, so it's going to be the same distance because we're assuming that, well, the trip is not going to change, and his speed is 10 miles per hour slower. So this is his initial rate, and now his new rate is r minus 10. And it says here, if the total time for the trip is 22 hours, find Mark's average speed on each part. Well, we don't know how far each part was. We don't know how far time 1 and time 2's part was, but we do know that time 1 plus time 2 is equal to 22. So if we can only figure out T1 and T2, we'll be all set. Now I'm going to change colors like I did in the problem before. I'll use green right now for my first equation. So I'm going to go 600 is equal to r times t sub 1. We're going to plug this in for this t sub 1 right there as long as I can isolate it. Divide both sides by r. So t sub 1 is equal to 600 divided by r. Now I'm going to use another color for my second equation here. I'm going to take my second equation, which is going to be my 600 is equal to parentheses r minus 10 parentheses t sub 2, and isolate to get my t sub 2 all by itself. Divide both sides by r minus 10, divide both sides by r minus 10, and what I get here is t sub 2 is equal to 600 divided by r minus 10. So I'm going to plug that in here. 600 divided by r minus 10. Switching back to my original color, this will then give me what I need here for my problem. So I'm going to add this here, and I'm going to set this equal to 22. Alright, now to solve this equation, the equation that I'm putting in this rectangle here, what I need to do is I need to clear the denominator. So I'm going to take that 600r, leave me some space, plus 600, and then r minus 10, leave some more space, and 22. I'm going to multiply everything by r and r minus 10. r minus 10. r and r minus 10. And what this will do, it will cancel out the denominator. Now the denominator goes away here and leaves me with 600r and then minus 10. So this is going to be 600r minus 6,000 because the minus 10 puts an extra 0 on there. Then I'm going to go distribute here. This is going to be the r minus 10s cancel out or simplify to 1, and this leaves me with 600r is equal to, distribute this here and here, this is r squared minus 10r. So 22 times r squared is 22r squared. And then I'm going to multiply by the 22 by the negative 10r, and this is negative 220r. Now I'm going to move all of my r's over to this side right here. So if I subtract the 1200r from the 220r, I get an answer of negative 1420r. If I add the 6,000 to both sides, this gives me plus 6,000. And now I'm all set up, since this is now equal to 0, since I moved all three of my parts over to the right, I am now set up to use my quadratic formula. A is 22, B is negative 1,420, and C is going to be 6,000, which means I've got negative B plus or minus the square root, and in this case the square root turns out to be 1,488,400. all divided by 2a, which is 44. Now, you'll notice that I said plus or minus, but I think by this time you're kind of seeing in these story problems, even though you're going to get two solutions, one solution is not going to be the answer, and it's usually the one that's being subtracted. Because this 1,488,400 is simplifiable to 1,220. So 1420 plus 1220 divided by 44 gives you a whole number answer of 60. And that way you can see that going one way, Mark traveled 60 miles an hour, and the other way, Mark traveled 50 miles an hour. Now, if you decided to subtract, you would get an answer of 4.5 instead of 60. Well, 4.5 could be kind of normal, but 4.5 minus 10 is impossible there, so our only answer is 60. So to find Mark's average speed on each part is going to be 60 in one direction and 50 in the other. Alright, well, thanks for watching. The second part is going to deal with the next three story problems, and the third part of this video will deal with the isolation of variables. So thank you for watching.